Find the area between two curves will be our objective for today. This is just an AP review question. Which of the following intervals, the first derivative is positive and the second derivative is negative? What are we looking for? Okay, and concave which way? Concave down, increasing. So I am increasing here, but I am concave up, so no there. I am increasing here, and so that one's a yes. Here I am decreasing, so forget that one. So the only interval is from B to C, so 2 ohms. Real AP question. Isn't that exciting? Especially when you don't have to make 100 on it. Okay, so one of the most common problems on the AP exam is to find the area between two curves. It is a pretty straightforward application of integration. If you have two curves instead of one, then would you agree if I wanted this distance here, you would do this top point minus the bottom point? Isn't that how you find distance? If you wanted the distance between two y values, you would just subtract the y's. Well, I can use that to find the area between two curves by integrating the top y value minus the bottom y value from the intersection point to the intersection point. And that will give me the area between the two curves, because it will add up all those teeny tiny rectangles with that height. So the formula for finding the area between two curves is the integral from a to b of top minus bottom, where a and b are the intersections of the two curves. And those graphs are why it works. I'll give you a minute to write. So this example that is graphed, the two functions are 2 cosine of pi x over 4 and x squared minus 4. Those two functions happen to intersect at positive and negative 2. That would be a calculator question mixed with the x squared and the cosine of x. We will do some where we have to find the intersections by hand, but with the x squared mixed with the cosine of x, that'll be a calculator problem.
Is it going to tell us where it intersects at the time, or?
No. Sometimes we will. Right. Which we will do an example like that. So this area, this shaded area here, is the integral from negative 2 to 2 of 2 cosine of pi x over 4 minus x squared minus 4 dx. That particular integral could be done by hand. For today, I'm probably not going to do a whole lot of the integration by hand just for time purposes, so make sure that you still are good at integration by hand, because these could show up on non-calculator tests. Any questions about how area between two curves is going to work? So now let's do an example. Find the area of the region between the graphs of f of x and g of x in the first quadrant. The hardest thing about area and what will be volume, which we'll do in a couple days, will be drawing the picture or having an idea of the picture. What do I really need to know from the picture? I need to know intersections, and I need to know what's on top and what's on bottom. So I'm going to sketch a picture really quick. This particular picture can be sketched by hand because we all know how to graph x cubed, and we all know how to graph the line y equals x. Which one is on top? And I kind of over dramatize my graph a little bit. You agree the line's on top because x cubed dips down a little bit? So my integral will be x minus x cubed dx. However, I need to know the intersections. Probably based on the picture, you probably already know them, but let's just pretend that we don't. How can you find intersections by hand? Set them equal to each other. Does everyone agree that would help me find where they cross, where they're the same? Get 0 on one side and factor. We get x equals 0, -1, and 1. Now, the -1 is perfectly correct as far as intersections go, but I don't care about the -1 because it wanted the area in the first quadrant. If it wanted both, then maybe we'd talk about the -1. We'd probably have to break it up into 2 integrals, but or we could use symmetry and double things. I am going to go ahead and do this integral by hand. (1/2 minus 1/4). That's what I get when I plug in 1. When I plug in 0, I get 0. So I get positive 1/4 is the area between those two curves. Any questions?
Are stuff like this going to be in like an open response task, or is it going to be in both?
Could be either place. Which I would say that's the way for most of the problems you've seen. They could go either way. They could make them multiple choice. They could make them open response. There is usually always on the AB exam at least one area volume problem. On the BC exam, I would say the same thing. There's at least one, but you wouldn't know if it's necessarily going to be regular area volume or polar area. But I would still expect an open response somewhere. It's one of the ones that you can almost bank on it being there. That accumulation integral defined functions. There's some that just almost always show up. And you'll get to see that when we do 4 practice exams. Which you'll get to do 8 practice exams. That'll be fun for you. That'll really help your score, though. You'll probably be really good.
On the last one, when you found the intersection,
Yes.
is that what you just plugged into the points? Or plugged in as the points?
The 0 to 1, because that's this intersection. So I'm looking for this area. And so this intersection is 0 and this intersection is 1. Find the area of the region enclosed by these 2 functions. See if you can set it up. Try to draw this picture by hand. It's been a while, but it's not impossible. Okay. All right. So, the graph. Parabola turned upside down, moved up 2 units. Everyone agree? And y equals -x is this line here. We don't have to have a perfect sketch. We just need, what do we need to know from the picture?
What's on top?
What's on top and what's on bottom? Would you agree that the parabola is the one on top? So the integral is 2 minus x squared minus -x or plus x. Make sure if the second function is more than one term that you use parentheses or distribute the negative.
So it can't, if you don't have to do the first?
The reason you need the parentheses is the negative, the minus the function. So whether you put them there or not in the first one doesn't matter too much. Set the two functions equal to each other. 2 minus x squared equals negative x. X squared minus x minus 2. Factors x minus 2 and x plus 1. So negative 1 to 2. Does that look right based on my picture? Check your answers with the reasonability of the picture, make sure it works. Now, if you are allowed to use a calculator on these, you can find those intersections in the calculator. This one is probably a non-calculator problem, as you can imagine. Anti-differentiate. Not when you're doing a definite integral, when there are endpoints.
Are we going to be doing indefinite ones?
No, because we're always going intersection to intersection.
How come we don't find, like, on the left side, there's like that little gap where the x is over the 2 minus x squared?
It says the area enclosed by. And so
the
this
x can't.
so this area is not enclosed.
So like the x equals 0, the y equals 0 is like considered a line.
Oh yeah, no, not on this one. Now sometimes it will say, Grant asked, how did I know it isn't this region here? There are problems that will say, find the area of the region enclosed by this graph, and the x-axis, which would switch it to a different region. So you always have to read the question. This one just said enclosed by the two functions, so it was pretty straightforward.
Are we going to do an example?
We will. 4, I'm just going to write it all out, minus 8/3 plus 2 minus negative 2 plus 1/3 plus 1/2. Does that look right? So, let me know if I'm wrong. Distribute the negative. The first thing I would probably do is put the 1/3 and the 8/3 together because that makes for a much nicer number. Negative 8/3 minus 1/3 is what? Try again.
Wait.
Negative 8/3 minus negative 9/3, and what is 9 divided by 3? 3. Negative 3. So those two combined together just give me negative 3, which is nice. 4, 5, 6. You can combine these any way you want. Plus 2 minus 1/2. 3, 4, 5 minus 1/2, 4 1/2. Do you have to do that? Depends. If it's open response, stop here. If it's multiple choice, are they going to stop there? No, so depends. Multiple choice sometimes is harder than open response because you have to get the answer that they get. So let me know if I'm wrong, because it's very possible. Okay, that background is hard to read. It looks a lot better on my computer than I did. Read this one. So what region are we talking about? Okay, this one here, right? Which brings up the first time we have a slight issue. Anyone know what the slight issue is? Okay, if I did top minus bottom and I started back here, I would pick up that extra triangle, wouldn't I? Now, yes, we could subtract, but I'm going to get more general on how to do this in general. Now, this one you could probably subtract a triangle if you decided you wanted to do that. But, in fact, that would be a great thought process if you think of it. But more in general, how to do this is I actually need two separate integrals because the top and bottom are different from here to here and then the blue section. Does everyone agree with that? What is the bottom on this first piece? It's just the x-axis, right? Which is y equals 0. Everyone agree with that? So I need two integrals to do this problem as it sits. I'll show you another option also, but so this one, because the top and bottom are not the same all the way across the region, I need two separate integrals if I leave it as it sits. So I would do the integral from 0 to here. Well, what am I looking at when I say here? Where the y minus 2 equals 0, where I cross the x-axis on the y minus 2 graph. Is that something I could find by hand pretty easy? 2, right? So 0 to 2 of the square root of x minus 0. Now, I'm not going to write the minus 0, but that's the bottom curve. Wouldn't you agree that's actually the kind of area we already knew how to find? We knew that the integral gave us the area under a curve. We never really thought about subtracting 0, but it makes sense where the bottom curve is 0. So that will give us the red area. The blue area, I'm going to color code. Let's see here. Will be the square root of x minus x minus 2. What's the top point there and how do I find it? Set those equal to each other. So square root of x equals x minus 2. I have to square both sides. To square a binomial, what do you do? Good. Foil, or if you had Miss Lowe, don't foil, whatever you want to do.
What does she call it?
Distribution, which is...
She doesn't call it foil.
No, because foil doesn't work if you have a 3-term times a 2-term.
Oh, yeah.
So she doesn't like the word foil because it limits you to only 2-term times 2-term, binomial times a binomial, which is a legitimate concern. But y'all are grown-up math students and can figure that out.
I think in 8th grade was when we decided what we wanted to use. So it was like 3 choices.
Oh, yeah.
One was distribution, one was foil, and then some else.
Yeah. It works, either way. And this does factor. X minus 1 and x minus 4. Everyone agree with that? Which one of those is this intersection? 4. It looks like it, right? Now, why did we get the -1? Well, remember when you square, it picks up this bottom parabola piece as well. And so it's giving you this intersection here, which I could care less about. But that's why you get two answers. And just for time purposes, someone just type that in the calculator for me. Just because I think you can integrate, right? This is a 1/2 power, add 1, we can do all of that, but for time-saving purposes, we're just going to type this in the calculator. And actually, I don't even, y'all just want to go on. We can do the integral. We agree. Okay. Now, I also want to give you another option for working this problem. X and Y are great. We've kind of gotten used to using them the way we use them. However, we are grown-up math students now. Y is x, x, and y, y. Could x be y and y be x? And just for the fun of it. Turn your head sideways this way. I'm going to do that. If you do that, and you look at this region, is there a clear-cut top and a clear-cut bottom? The other way. Actually, technically wouldn't matter, but we want the positive one, which is to the right, to be the top. So.
No, there's not.
Oh, sure there is. Isn't this always on top? If you are looking at it with your head sideways, isn't this always on top?
Yeah.
Yep.
Why is that not the X or the Y? I mean?
So maybe we could integrate with dy as our variable. And the top curve being the right-hand curve and the bottom curve being the left-hand curve.
So we do.
Now, would you agree we would have to have the variable being y? Okay, so let's go back up and look at the functions. One was y equals x minus 2. Would that be terrible to solve for x? Wouldn't x just be y plus 2? Okay. That would be the top. Right? You agree? And the bottom would be, what was it, y equals square root of x? So y squared equals x. That would be the bottom. So we could do top minus bottom. Now, we have to be consistent. We used y's here, right? So what needs to go here? Y's, correct? What is the bottom y value of that region? What is the top y value of that region? And you may say, I don't know. But wasn't this at x equals 4? Couldn't we find out really quick what the y is? 2? You could plug it in here, or you could plug it in here. Make any difference. So 0 to 2 on the y-axis. Easier integral? Only one. Probably easier integral. I don't have any 1/2 powers to work with. Gives you the same area. So, we learned something new. That we could work right to left or top to bottom. You have a question, Scott?
It has to be right to left every time.
Should not be an acceptable way to split notes.
Why not?
I feel like if I had done the test, I would be dumb.
Why? I think you would look quite clever.
Just like flip X's and Y's, it's wrong.
Why not? What makes x, x, and y, y?
Apparently.
You've been lied to your whole life. I'm just teasing. Okay, so anyway, you can do that either way. Now you know. Now sometimes it's not beneficial. Like this one, would you ever want to solve this for x? No, this would never be beneficial to do a dy. But there are some that are, so we've seen one. We'll do more examples Monday, I promise. Okay, find the area of the region bounded by the following equations. What's the problem? There are two pieces. Everyone agree? If I want the whole area bounded, I want both of those pieces. But this one I have no way around it. I will have to do two integrals. I can't clever my way out of two integrals on this one. On the red piece, what is the top? The cubic. Everyone agree it's the cubic, not the line. Sometimes on the non-calculator part, they'll give you something like this where they show you the picture. You just have to pick out which one's the cubic and which one's the line, which y'all can do. X cubed plus 2x squared minus 3x is the first piece. Second piece is backwards. Put it down here. 3x. Make sure we put parentheses here. X cubed plus 2x squared. Did I do something wrong? Yes, you can just change the signs if you get rid of the parentheses. Just be careful, make sure you change both. But if you do, yes. I still need to know what? Intersections. Subtract the 3x over. How are we doing? Besides turning your world completely upside down. Besides that. We're doing okay on area. X squared plus 2x minus 3. X plus 3 and x minus 1. So the red piece will be from -3 to 0, and the blue piece will be from 0 to 1.
So you don't have to work from the right. You can do it like the right side because it's just.
This one I'm doing top minus bottom. This one I'm doing normal.
Yeah, I mean like if it has the two areas, you have to top. Like can you start with the blue side and go right?
Sure. Yeah, as long as you integrate 0 to 1 and -3 to 0. Use a calculator to find this. You'll still have to set it up, but what does the calculator do for you? That's the intersections for you. This worksheet is not due on Monday. It would be due Tuesday, but be here. So you definitely won't be here this year. I didn't hear it with me anyway. Do you think they're gonna make us?
What time are y'all getting?
It's a real ACT.
So it'll be down at 12.
Probably a little later because of the.
Is it tomorrow's class?
No. Tomorrow is Tuesday.
Oh, okay, so you know what? No, today is when they fill out this.
Yeah, today we're just bubbling the 1 hour thing today.
Yeah.
Tuesday is the real ACT.
Oh, this thing in the first percent is just practice.
On Tuesday, the 11th graders take a real ACT. The sophomores do a practice ACT. But the juniors on Tuesday are taking a real counted ACT.
So what are they doing after they take the ACT?
Don't know. It's a good question.
They're gonna make us come back. I'm really sorry.
Yeah.
No, watch them make us come and just sit and do like a June full.
Oh my gosh, that would be so fun.
Listen to some public speakers.
And Miss Adams' dad, he was okay. I'm recording. All right. Any questions about the picture? Okay, the calculator will help you find these values. Okay, I do want to show you a calculator trick. When you go to second trace 5 and do an intersection, I have a different function in here, but you can imagine. I want to show you a cool calculator trick though. When you go to second trace 5 and push enter 3 times, you see that intersection that it gives you there? If you go to your home screen right now, with your cursor still left there on the intersection, and type X, store as A, it will put that intersection in your calculator as A. That way, when you go to do the integral, you can do the integral from 0 to A, or whatever you need to do, or from A to B, and those values are correct. Remember, the AP Calculus exam expects accuracy to 3 decimal places. If you use a rounded intersection, could it mess up your decimal accuracy? So you want to use an exact value for that intersection. This is how you make your calculator do that for you. Any questions about that? So, just a cool calculator trick. So I'm going to integrate. Clear cut top is the cosine function. Clear cut bottom is the polynomial. And I would say from intersection A to intersection B. Were they whole numbers? I'm guessing. And then you would type this thing in your calculator. Okay? We'll finish this one today.